Hi, welcome to this presentation on What You See is What You Ask, Evaluating Audio Descriptions. Audio descriptions, or ADs, help blind and low vision users follow movies and shows. They run alongside the soundtrack, complementing it. ADs avoid overlapping dialogue unless it's crucial to the story. While writing ADs, the writers must ask themselves whether to say something, when to say it, what visual aspects to highlight, and how to phrase it. Now let's take a look at current AD generation and evaluation methods. This is a sequence of consecutive clips from a movie, and these are the ground truth ADs associated with these clips. Notice how the first clip doesn't have an AD because it has a dialogue. Because of the way datasets are created, it is possible that an AD might not align temporally with the event that it describes. We isolate one of these clips and call it our trim clip. These are often just few seconds in length. This trim clip is sent to an AD generation model to predict ADs. The current evaluation method then compares this predicted AD with the ground truth. This single reference sentence pair comparison is how ADs are currently evaluated. But this framework is problematic for potentially misaligned ADs and visuals because the events to be described may not exist in the trimmed clip. Take a look at this video, where each AD is predicted by giving a trim clip to Auto AD3. Observe that the predicted ADs are non-descriptive and redundant, as should be expected when ADs are generated using isolated trimmed clips. Next, we'll dive into whether single reference sentence pair comparison is the right way to evaluate ADs. We will now try to quantify the inherent subjectivity in AD creation. We start by aligning two independently authored AD tracks. We find that 40% of the ADs are not aligned, indicating that AD creators do not agree on whether and when to write ADs. In fact, even at a very low overlap threshold, 25 to 30% of ADs remain non-aligned. This fundamentally challenges the validity of single reference sentence pair evaluation. For the remaining 60% aligned AD pairs, we plot them on this cider versus bird similarity graph. The first quadrant fills up with pairs that describe the same detail with similar words. Metrics like cider capture these pairs well. The second quadrant contains pairs that describe different details, but happen to use the same words. The rare word barn results in high cider, even though the ADs highlight different details. The third quadrant contains pairs that describe completely different details. N-gram and semantic similarity based metrics perform poorly on these. Fourth quadrant has pairs that describe the same detail but with different words. Finally, around 27% of the pairs score 0 on cider. To summarize, subjectivity in when and whether to describe manifests as up to 40% of the ADs being non-aligned, raising concerns about sentence pair evaluation. Subjectivity in what to describe leads to poor performance of semantic similarity based metrics, and subjectivity in the how leads to poor performance of n-gram based metrics. Thus, single reference sentence pair evaluation on isolated trimmed clips is not adequate. Then how do we evaluate? A seminal work by Dr. Joel Snyder on audio descriptions quotes the often referenced first rule of ADs: what you see is what you say. This means that an AD writer must not interpret and should provide facts objectively. It also says, when an AD writer is faced with questions like whether, when, what, and how, the writer must always ask, does it help the audience understand the narrative more, and does this choice enhance the audience's appreciation of the visuals? It is clear how ADs help users understand the story better. An example of how ADs help users appreciate the visuals is now shown.
Axel turns to face the helicopter and growls in slow motion. 3, 2, 1, 0. Flame erupts from every seam of Axel's panels. Fragments fly away like shrapnel. A large explosion hurls a shockwave through the air as dark smoke rises up. In the back seat, Sarah looks out the window.
We now introduce our approach towards AD evaluation. We create ADQA by shifting our evaluation paradigm from does it match the ground truth to does it help the end user. For this, we move away from few second long trim clips to few minute long video segments. Now shown is few seconds from a video segment of the movie Liar Liar. The boy Max makes a wish, then blows the candles. The curtains move behind them. We start with ADs and dialogues from the first AD track. We also extract plot summaries for each video segment. We use the first AD track to create a visual appreciation question. and the plot summary to create a narrative understanding question. A second AD track, human authored or predicted, will be the answering context to answer these questions. This context is used to answer the visual appreciation question and the narrative understanding question. ADQA consists of 98 movies from CMDAD and 10 movies from Madhuval. We release a smaller public set of ADQA for local evaluation. Notice how the narrative understanding questions are about the overarching story, while the visual appreciation questions are about immediate visual details. Benchmarking AD generation. We conduct experiments to figure out how different context types and popular AD generation methods perform on ADQA. The setup of all experiments is that Gemini 2.0 Flash is provided with questions, options, and a specified context, and is asked to answer questions independently. A problem arises. LLMs may avoid the context and use prior knowledge or reasoning to answer questions. To counter this, we ask the model to generate the answer, a rationale for choosing that answer, and a binary variable answered using context. Based on this binary variable, we define three accuracy metrics. CA counts the number of correct answers, AC counts number of answers which had the boolean answered using context as true, and CC counts answers which were both correct and answered using context. Another problem we must solve before going ahead is that not all ADQA questions can be answered. This is because even human-authored ADs do not always agree, so it is unreasonable to expect a model to score 100%. Accuracy ratio measures gap closed between human ADs and dialogue-only baseline. We conduct context ablations using both datasets and question types. We use AudioVault Track 1, 2, LSMDC, and plot synopses as question and answer sources as applicable. We show correct answer or CA accuracies for no context and movie name only context types, and correct and context-based or CC accuracy for rest of the context types. We see that requiring a rationale based on context decreases the accuracy for CMDAD. This indicates that the LLM struggles when forced to justify answers using context. For Madhuval, the dialogue plus AD accuracy increases. This hints at a stronger agreement between AudioVault and LSMDC. For visual appreciation, dialogue-only context leads to lower CC compared to AD only, highlighting that ADs convey essential visual details missing from dialogue. For narrative understanding, dialogue only outperforms AD only, emphasizing the importance of dialogue in driving the story. However, for both datasets and question types, the best results consistently come from dialogue plus AD. For both datasets and question types, we see a consistent trend. Enriching the answering context improves CC accuracy. Now, we compare popular AD generation methods on ADQA. On CMD AD narrative understanding, AudioVault Track 1 and AudioVault Track 2 achieve similar CC scores. Likewise, LSMDC and AudioVault Track 1 reach similar CC scores on Madhuval narrative understanding, thus validating the benchmark. As we shall see, human ADs outperform all methods across both datasets and question types. For narrative understanding, dialogue only provides a strong baseline for CMD-AD. In contrast, for Madhuval, ADs from most models do not surpass this dialogue only baseline. Narrated, that uses scripts and shot by shot, stand out. For visual appreciation, dialogue only is a good baseline and all models are able to outperform it. While Narrated achieves the highest score on Madhuval narrative understanding, it uses movie scripts which are not always available or aligned with the final cut, so we don't include it in the best performer comparison. Shot by shot achieves highest score on both datasets across both question types. Since it extends temporal context to neighboring shots, this indicates that it is indeed important to look beyond the trimmed clips. We end with future recommendations. We should move from short clips to longer videos for more coherent ADs and train models to build narratives, not just describe isolated events. Scripts can help but aren't always reliable, and we need grounded evaluation following AD guidelines. Thank you for tuning in. For more details, please scan this QR code.